In the last video, we showed you how to get a basic UART working using the data sheet as a primary programming reference. In this video, we'll try and get slightly more advanced interrupt-based UART communications working, but using some of the great application notes on the Atmel website. So let's start there. So going to the AVR 8-bit products, Mega AVR, looking in the Documents tab, and selecting Application Notes. So here there's quite a range. I'm going to look for UART in C. Well, I knew that I was looking for that one. There's quite a few. But here is an application note describing the application, and the zip file typically contains some source code. So I have downloaded this already. So let's have a look at the PDF. We've got some code examples of polled and interrupt-based UART, compact code, and for the interrupt-driven UART, we generate an interrupt when the UART is finished transmitting or receiving a byte, and the interrupt handling routines also use circular buffers. That's quite nice to see. Okay, so let's have a look at the code. C files are associated on my computer with Atmel Studio, so it directly opens here, and I can see quite an extensive file here, and I'm going to copy this code from just below the include, because it's an include for a different Atmel microcontroller, so well, a different AVR microcontroller. So I'm going to copy this code, and I'm going to just comment out my existing UART code, and paste this code just below the include. Okay, now I should be able to go through the code and just look for anything which doesn't quite fit. First of all, remember that this is interrupt-based code, so we should go back to libc and remind ourselves that for interrupts we need the AVR interrupt.h file. Okay. Next, we see say. Now remember, that's to enable global interrupts, and it's defined as say. Well, in small letters in libc. This code looks like it was written for IRR. So there's some small differences. I see the UART init here. Now remember, we used a macro before, which was my UART baud rate register. And so let's pass that to the UART init rather than hard coding it. Let's keep looking. Okay, so in the UART init, we see that this is quite similar to before. The difference here is that there's an interrupt enable. We expected that. We don't see a transmit interrupt enable, but we'll look for that. Then the stop bit was something that we actually changed from the example code in the data sheet in the last exercise. So I'm just going to take this out because I remember that that was about 2 stop bits and we want just 1. Look at the last video to refresh yourself on that. Okay, now I see that we have some things with the interrupt vectors, and this is the way that IR does the interrupt vectors. libc works like this. So and it's the RX vector that we're wanting. Now, if you want to have a look at all the interrupt vectors for a particular microcontroller, I'm going to go Alt plus G to go to a definition. And here is it's a list of vectors, but this is part of the include file for the particular microcontroller. So I came from the UART receive vector, and remember it's the data rate register empty, which is the equivalent of our transmit vector. So that's what we needed here. Okay, and remember I mentioned something about the transmit and the transmit interrupt. Well, that's what actually happens. You call the transmit function, and in that function it enables the data rate empty interrupt, which means that all the data has been sent. Otherwise, let's run and see if this works. Okay, connecting our terminal program, and it works. Thanks. And just to confirm now, as we have before, let's debug and make sure that as we send a byte, so we will set a breakpoint in the UART data rate empty vector. And we get stuck in this interrupt just as we've sent something, and if we push play, we see that every character that's being sent we hit, and you can see the individual letters appearing as we step to this breakpoint. Thanks.